If I want to hold just 1 unit on average for the whole year, my cost is H, the holding cost per unit per year. But what is my average inventory? We have gone through this in the last couple of slides. The average inventory is Q by 2, or half of Q. Remember, we went from Q to 0, so on. So the average inventory is half of Q. So my annual holding cost is Q by 2, which is the average inventory, times H, which is the holding cost per unit per item. Finally, what have I done here? I have equated the two, the annual holding cost and the annual ordering cost. Don't forget why we are doing that. Because the optimal quantity to order is the quantity at which the total cost is minimized, which also happens to be the quantity at which the holding cost and the ordering cost intersect. That is, they are the same. Remember the blue and the green and the red curves. So here we are looking at the ordering cost, which is D by Q times S, is equal to the holding cost, which is Q by 2 times H. Now I'm solving for Q to give me the Q star, the economic order quantity. So the simple steps of doing that is shown here. So the Q star, or the economic order quantity, is square root of 2ds divided by H. H is also the same as I times C, which we discussed. So the EOQ formula can be plugged into the computer. Once you know the annual demand, once the company has specified the ordering cost S, once the company has determined the holding cost H, which is nothing but I times C, as we have discussed, you know what the optimal quantity to order, the economic order quantity, square root of 2ds by H. And keep in mind, the square root is for the entire expression. I've seen in classes students make a mistake of not taking the square root for H and only for 2ds. So it is for the entire expression 2ds by H, square root of that. Thank you. Let's look at a very simple example here. In this example, we will determine not only the economic order quantity EOQ, but the time between orders, as well as the annual holding cost, ordering cost, and the total cost. So let's look at the example. The annual demand D is 1,000 units per year. Keep in mind, if the demand was not given as annual, convert that into annual. S is the ordering cost, which is $10 in this case per order, and H is the holding cost per unit per year is 50 cents. How did we get that? We would have obtained that by the formula I times C, I the percentage, C the cost per unit. Given all this, calculating Q star is pretty straightforward. Plug that into the formula, square root of 2ds by H, and you will get 200 units. That is my economic order quantity. I am ordering 200 every time I place an order. So let me ask a simple question. How many orders per year? If you're ordering 200 every time, and if your demand is smooth, and your annual demand is 1,000, you are placing 5 orders a year. Go to the next slide. Here we are looking at the expected number of orders, which I already explained. It is 5 orders for the year. We have divided 1,000 by 200. So if you are a formula type person, you know what to do. D by Q star, which is 1,000 by 200, 5 orders a year. Here you're looking at the expected time that has elapsed between the different orders. So you're ordering 5 different times. How many working days are there? If you want to just look at the working days, assuming you're not working on Saturday, Sunday in this particular manufacturing company, so you have 250 approximate days between you have 250 approximate working days in a year. So 250 divided by 5, every 50 working days, you place an order for 200 units. The last slide of this example looks at the total cost. So you remember the total cost. Total cost is the combination of the holding cost and the ordering cost. And in some places, if you're looking at the total cost, you also take into account the purchasing cost. That is, cost per unit times the total demand. Here I'm excluding that because whatever the quantity that you order, you still have to pay that amount because there is no discount here. So if you're ordering 1,000 units in the whole year, you got to pay for that. But in some cases, when you're looking at total cost, you add the cost of the units also. But here, let's look at only the holding cost and the ordering cost. Ordering cost is S times D by Q. So you have all the three numbers now. S is only $10. D is your annual demand of 1,000, and the ordering cost is 200. So do the math, and then you have total holding cost is Q by 2 times H. So you know Q, which is 200. You know H, which is only 50 cents. So if you do the math, you are going to get $50 of ordering, $50 of holding. That gives me the total cost of 100. Now keep in mind, if I got an answer of 50 for ordering cost and 80 for holding cost, do you see a problem? Yes. If you got a different holding cost from an ordering cost, it means that either you calculated Q erroneously or you made total cost calculation wrong. Because keep in mind, the holding cost has to be exactly the same as the ordering cost. That is the whole idea. That is the economic order quantity. Economic order quantity is the quantity at which not only the total cost is minimized, but the holding cost is equal to the ordering cost. So our economic order quantity in this example is 200, resulting in $100 of combined holding and ordering cost expense. Remember, we already found out how to calculate the ordering cost and the holding cost. The ordering cost is D by Q times S. So our demand in this case is 1,000. Q, the quantity that we said we are going to order, which is the EOQ, is 200. S is my ordering cost, which is only $10 here. So if you do that math, you'll get the total ordering cost. The total holding cost is Q by 2 times H. Q is the quantity, again, 200 divided by 2 times H, which is the holding cost per unit, which is only 50 cents. So if you do the calculations, you find out that the total cost is equal to the ordering plus the holding cost. And the ordering cost is $50, holding cost is another 50, the total is $100. So that is my cost to order 200 units every time for 5 times in the year. Now keep in mind, what would happen if my ordering cost turned out to be 50, but my holding cost turned out to be 80 in this calculation? Do you see a problem? Absolutely. You cannot get two different costs for holding and ordering. That is the whole idea. The holding cost is equal to the ordering cost at the economic order quantity, meaning Q star, the ideal quantity or the optimal quantity to order is not only the total minimum cost, but also the quantity at which the holding cost and the ordering cost intersect. So if you have made a calculation mistake, only then you will see the holding and the ordering costs being different.